Very good evening to all, and I hope you people are doing well and good. I welcome you to SM Techno. Let's move on with the session. So as you all know that today we're gonna start up for the plumbing demo here. We all are here for a plumbing demo. So in this demo session, we'll be starting up or discussing is all the plumbing, the chapters and the detailing here. But before that, let me introduce you myself. My name is Habib Ahmed Chisti, and I'm gonna be your plumbing tutor. And my qualification is BTech Mechanical. I hold almost like 12 years of experience in MEP field. As we all know that what we are discussing actually it's a part of MEP. And if you wanna be an MEP engineer or MEP graduate, then you people should update yourselves with HVAC, electrical, plumbing, and firefighting. Okay, so as I said, we are dealing right now with only a part of MEP demo, that is plumbing demo here. Okay, so let me just begin up with this. So in today's session, we'll be learning is the demo, and we'll be learning about the plumbing, that what are the things we're gonna learn in this course and what are the benefits of this course and what you can do once you have completed this course. Okay. So let me just begin up with, so as we all know that this plumbing, and before that, if you can see here, as SM Techno, we deal up with entire MEP. You can see HVAC, electrical, plumbing, and fire. If I club this all four courses, then you people are learning is MEP. And afterwards, we do have Revit MEP and Revit Architecture too. So these are the courses which is offered by SM Techno. One can enroll for and boost their careers. Okay, moving on with plumbing session. So as I said, this plumbing is divided into two parts technically. First of all is like the water side, and second is the drainage side. So we'll be discussing first of all in the water side, what are the parts we're gonna learn, and in the drainage side, what are the parts we're gonna learn. So there are some things like mostly we deal up with many standards like IPC, NBC, UPC, and we deal with NVC or NPC also. But mostly we follow, or I follow, is IPC standards, because we know that we can't find all the details in one code. For example, in simple words, if I say if you people are familiar with, if I wanted to design a heater or select a heater or do the calculation for the heater, I don't find the inputs in IPC code. For that, I need to go for ASHRAE. Likewise, if I tell about the manhole sizing or something like that, you don't get the details in IPC. You need to go with international standards with some code of that. Okay, that is again a local code from India, that is Indian standards. Okay. So, but mostly the things what I take from NBC and IPC, and not only this, as I mentioned, there are many codes which will be coming up with, because as I said, now we don't get all the things only in one code, because we know that some codes are specifically mentioned for some certain topic. So for that topic or for that concept, you need to follow that code. Okay. So just to highlight this, we'll be mostly dealing with the international plumbing code, that is IPC and NBC. Rather than that I said, like, we will be coming across ASPE, ASHRAE, and many more. Okay. So these are the softwares or kind of Excel programs what we're gonna use it. So we're gonna use this like pipe sizing Excel program. The source is from ASHRAE, and you can update it by yourselves. Very simple, by just changing the values as per your code, and that Excel sheet will be becoming what you need. Okay, but this ASHRAE, this Excel program with me, the source is from ASHRAE standard. Okay. Pump sizing Excel program, we'll be dealing with pump sizing in a manual form as well as in an Excel form. Okay. Then third is we'll be dealing up with the tank sizing in a manual. After that, we'll be dealing up with the sizing of tank by means of an Excel program. Same with heater sizing, that is central water heater or unit water heater. We'll be dealing up with manual heater sizing. Then afterwards, same thing, we're trying to repeat it by means of Excel program. Apart from this, we will be dealing up with one complete villa project, that is Villa A, that we come across. And that Villa project A, we'll be dealing with the complete pipe designing Okay, first of all, you need to read the architecture layout. We'll let you know to how to read an architecture layout. After that, select what kind of system we need to. That depends on many parameters, like where is the project located and what is the client requirement and atmospheric conditions and the municipal authority, how much water is available. There are a number of conditions we'll be dealing when we go into the course. Okay. As of now, as I said, we'll be dealing with the villa project, that is complete villa project in the water side. So in this water side, we'll be studying the architecture layout. We'll be sizing up the entire piping that respects to cold water pipe sizing and hot water pipe sizing, as well as after that, we'll be dealing up with the central electrical water heater or the unit water heater with regards or with respect to the villa project same. Okay. And water hammer arrestor sizing and pump sizing. So in simple, we're gonna deal up with the entire equipment and the piping or entire plumbing system, I can say, in the water side. We'll be dealing up with one villa project, and this villa project is being designed, or this we used to be a consultant. So this design of the villa project has been given by SM Techno, and so far the villa is being executed almost a decade ago, and it is working so far fine. Okay, so that is the reason also we have included, because that's a real kind of project what we have dealt up in the previous days. Okay, Villa C also will be dealing up with. There were 3 villas, A, B, C, what we used to deal, that was typically number 100, 100, 100 in some Gulf country. Okay, so in Villa Project A and Villa Project C is something different. Villa Project A was direct supply system. In simple words, if you are new here, direct water supply system refers to there is no aid of any pump or there is no aid of any underground tank and all this. But in Villa C, the scenario was different. We was having a booster system over there. So almost it's both are residential, but here the water is being pumped by a means of a pump, that is by booster pump. So that is only the difference. So why we included that? Because as we have done the calculation for the booster pump in the Villa C, so just to upgrade yourselves or just to know that how the calculation for the booster pump would be done. So that is the reason we have done here. Okay, because in Villa Project, there is no pumps. So just to get the concept, so we have included the Villa Project C in our project. Okay. Now, as I said, once again, there are 2 parts in plumbing. Part 1 is the water side. Part 2, sorry, there are 2, you can say, I can say is like 2 modules, like module 1 is water side, module 2 is the drainage side. So module 1, as I said just now, is water side. In this, we have n number of chapters. That list, for example, 14 chapters. So in part 1, and that 14 chapters is subdivided into parts, like numbered as 1 to 6 parts. Okay. Now, in part 1, if you can see here, there are 3 chapters. That is chapter number 1, 2, and 3. So what you're gonna learn in the module 1, that is water side, chapter 1 in part 1. So part 1 covers 1 to 3 chapters, and the chapter 1 is nothing but introduction to the building. That means, what do you mean by a different kinds of the plumbing system? Because we know this, there are different kinds of building, like one is commercial, residential, and industrial. Okay, so in all the aspects, you need plumbing to be done. So we'll be giving you what is the benefit or what is the significance of the plumbing industry in all the projects. Okay, first of all, we'll be introducing you to the building services, that is nothing but MEP, you can say, and more. And we'll be introducing you to what is plumbing, then what is a plumbing system. As you can see here, introduction to plumbing, what is plumbing and what is plumbing system, classification of plumbing, then what is the standard societies and codes or application handbooks, what we're gonna use and why they are used. We'll see that also. So what is plumbing code here? Why and what, both is mentioned. So why to use this and what it is. So you know this. Okay. So we'll be getting some clarity about the codes and all this. So we'll be getting a definition. What is a plumbing and what is a plumbing system too here. Okay. And after that, we'll be learning is about the simple chemistry of water. because we know this here we are dealing with fluid that is nothing but a water. So we'll be learning about what exactly the water is, the scientific names and all this, and why it is termed as H2O, some basic information about that fluid. Then afterwards, what are the plumbing fixtures? Now, for your information, if you're not aware, I'll give you a small introduction to that. Plumbing fixtures is something which is an exchangeable device of fluid. That means, like example, I can say a shower, WC, urinal, kitchen sink, bathtub. These are all plumbing fixtures which demands water. At the same time, the water needs to drain out from that fixtures to maintain a healthy atmosphere within the building. Okay, and without fixtures, there is no habitable place for humans, because these, when they have been arranged in a systematical order and or when they have placed in a building, that makes life easier. Okay, so these are the fixtures what we'll be discussing over here. Like you can see, the very first fixture we'll be discussing about the WC. In this WC, there are types of WCs. One is European, Indian, and universal. Okay, so we'll be letting know this, what are the different kinds and how they look, and why we are learning or why we are discussing this chapter number 1, okay, in the part 1. The reason behind that is one should know this, what are the plumbing fixtures. Not only you should know, you should also know that what plumbing fixtures demands what kind of water. Like as we know this, like example, if I say WC is something which is used for humans, which carries or which is used for like human waste and all this. So here we mostly use for the WC flushing, and we for the perennial spray or the hand spray or hose for WC, which we say, which is right beside on the right side mostly of the WC, that both for the flushing and that perennial spray or the hand spray both demands cold water. So one should know this idea, or one should know the information that what fixture demands what kind of water, so that it makes us easier to design the system. Because if you know this what kind of system, then you count in the fixtures as per the service that is to be provided by that fixture. Following everyone? Yes, please. So this was about the WCs and all this. So there are 3. We'll be seeing the classification further when we move on. This is just a demo, as I said. So we'll be seeing that later on. Okay. Second thing, for the flushing of the WCs and urinals. Mostly in houses, we have gravity flush tanks. Okay, which is we use it for the flushing purpose for the WCs. And a standard IPC says that 1.6 gallons of water has been flushed out in one flush. This is as per IPC. Remember this, okay? And after that, we do have a flushometer tank. What do you mean by a gravity flush tank and a flushometer tank? There are 2 different things. So make sure whenever you are dealing with any kind of project, you need to get some inputs, okay? That means input in the sense, it depends on the kind of project. For example, if I say, if you're dealing with a commercial project will be having a flushing system mostly with a flushometer valve or flush valve. The reason behind that flush valve is the occupancy for that WCs or urinals in a public toilet is more. Okay, or public application is more. The reason behind that is it's in public category. That means the usage of that fixture would be more when compared with the domestic. For example, if I'm dealing with a residential bathroom or a toilet area, we don't have gravity, or we don't have is like flush valves over here. We have is mostly gravity flush tanks in our houses, because the probability or the chances of using the WC or the urinal in the residential application is not as high as in the public application, because this might be, we might get some time. Okay, so that's the reason we don't. So as was discussing about the flushing system, so in this flushing system, we use flushing mechanism for the WC and urinal. So there are 3 kinds of flush what we see generally. One is gravity flush tanks, which is a reservoir or a tank which we see generally in our houses above the WC. That is nothing but a flush tank. And one is a flushometer tank and one is flush valve. So I said the difference between these 3. So flush valve or a flushometer tank is something else, and gravity flush tanks, what we see is a very common thing. Okay, and as per IPC, as I said, they says that in one flush, in a gravity flush tank, 1.6 gallons of the water is being flushed out. Okay, in one flush. Okay, so after this, let's move on below. Still we are in the part 1 and the chapter number 1. After that, flushing system, we'll be moving on and seeing the next picture, that is nothing but a laboratory. In laboratory, we do have different scenarios. For your information, laboratory is nothing but, I can say, is wash basin, to make you people understand in an easy manner. So we have single laboratory with pedestal, and laboratory tray. So we'll be seeing this. What do you mean by these three different things? Laboratory tray, laboratory with pedestal, and laboratory or single laboratory. We'll be seeing what is the major difference. But as of now, technically, laboratory is nothing but a wash basin which demands cold plus hot water. Remember this, because as I just now said, that we are learning this chapter number 1 in the part 1 in the module 1. The reason behind this, one should know this, what kind of fixtures you are coming across and what that fixtures are demanding, what kind of water, either cold water or hot water or both. So once you have a clarity, then you count on that fixtures and you adopt the values from respective code, so to size up the pipe size. Okay, so that is the reason we are learning, or we'll be discussing this, because I know that many people are aware of this. No need to repeat this, but still those who are freshers and all this will be counting on some easy way to tackle them with the scores. Okay, so next picture is nothing but a bathtub, which is used for having a bath. In this we do have two categories. One is bathtub, normal one, and one is whirlpool bathtub. What is the technical difference between this? We'll be seeing this in the chapter number 1 when we start the actual course. Okay, and but both bathtub refers for the bathing purpose, so it demands both, that is cold plus hot water. Remember this. Shower is also again used for, the next picture is a shower. Shower is also used for having a shower, I mean a bath, you can say. So in this, we do have some categories. One is wall-mounted shower, one is hand shower, and one is shower tray. Shower tray is something just to collect the water, that the water should not enter into the surface of another area. So that's the reason we have a shower tray, where the water would be going with some slope and connecting into that tray, and that would be draining out. Okay. Hand shower is something which is movable. Okay. And wall-mounted shower is fixed shower that has been, or I can say, which is installed at the wall at certain height, like 6 feet or 7 feet. This differs from the region to region as per the human stays over there. Okay. Next fixture is nothing but the bidet. Bidet is a fixture which is most commonly found right beside the WCs. It is used for the hygienic purpose, okay, for the cleaning purpose, you can say. And next fixture is nothing but, the next fixture is floor drain, and another is a urinal, and next is kitchen sink. After that, we'll be coming across the drinking fountain, where we use it for the drinking of water in a public places. And cooling tower, why we have included the cooling tower? Because for your information, everyone, the firefighting piping or the HVAC piping, even that piping also comes under the plumbing industry, but we don't deal up with that. That is like, I can say, is like done by HVAC or firefighting engineers. But that set of piping, whatever I say, either in terms of HVAC or firefighting, that all comes under plumbing industry only. Okay. The next fixture is a water taps. Under taps, you'll be learning what is the difference between a tap and a faucet. So we'll be learning here. And what is a hose bib here, we'll be learning. Then dishwasher, this is an equipment or a machine, or which is used for cleaning up utensils, and washing machine, and electrical water heater. Electrical water heater, as well as we have a solar water heater also, but here is not mentioned, but we have that concept. We'll be learning that and designing that. So again, in the part 1, as I said, part 1 consists of 1, 2, 3 chapters. Second chapter in part 1 is nothing about, we'll be dealing about or learning about the plumbing equipments. In this, first of all, we'll be learning what are the types of the pumps. So we know this, there are different kinds of pumps. Like you can see here is a very first kind of pump. Here is a transfer pump. Second is booster pump. Third is hydro booster pump. Fourth is hot water circulating pump. So there are 4 pumps over here. So we will be discussing and we'll be trying to get the knowledge that what exactly a transfer pump is meant to have in a building. What do you mean by a booster pump? Why it is installed and how to do the calculation. So we'll be dealing the pump head calculation for the transfer, booster and hydro booster and hot water circulating pump. So but here as now as in the chapter number 2, you'll be just getting the information that why these pumps are being needed and what is the purpose to install the pumps in this this project, okay, as per the need, and why and what these pumps are meant to be done the water side. Okay, after that we do have is like a submersible pump which is totally submerged into the water, where we have generally in our like bore wells we do have submersible pump that are submerged into the total water. After that we'll be learning about the pressure tank or the pressure vessel. Okay, and next is a dishwasher. So heater, in heater you have categories, as I said, one is unit water heater, central electrical water heater, also called as a boiler, and next is a solar water heater. After that you can see the next equipment you can see is here is a grease trap or a grease interceptor. So we'll be learning technically what is the difference between a grease trap and a grease interceptor, because many people have a confusion that it's one and the same. It's the mechanism is same or the function is same, but there is a technical difference. What is that? In the drainage side, when we move on with, we'll be seeing this and we'll be designing this too also. It is a grease trap designing and grease interceptor designing. Okay, and for your information, next, hair interceptor and oil interceptor. So what do you mean by interceptors, hair interceptor, oil interceptor? Actually, this is a part of like the drainage side. So we'll be seeing more in that. Here in the chapter number 2, you will be getting an idea. What do you mean by a grease trap? What it is done, like hair trap and oil trap, and how to design we'll be dealing with in the drainage side. Okay, next, chapter number 3, again still we are in part 1 of the water side. Here we will be learning is about pipe fittings and accessories. Here you will be seeing what are the different kinds of the fittings, that is like elbow T, reducers, cross and all this. These are all fittings, and accessories like pressure gauges, thermometers, and I can say many more. So these are accessories. So we'll be learning this like what are the different kinds of fittings and accessories. I'll just list out quick. But the pipe fittings, under that first of all we'll be moving on and moving on with 45-degree elbow and 90-degree elbow. So we'll be seeing this where elbows is being placed and what is the reason here, and the reason why we are learning the chapter number 3 here, everyone, because see, if the water side to make a plumbing system, we need a set of piping, right? So the set of piping can be connected by means of some fittings, right? And by means of some accessories, you can do the maintenance, or you can do measure how much amount of the pressure is being passing by. Like example, I'm talking about the pressure gauge, or I can say the thermometer. You can measure what is the temperature of the water and all this. Okay, so if you would like to change the direction of the water, or if you would like to connect one pipe to another, you need some fittings. Without that, you cannot. But we are learning here the chapter number 3, fittings and accessories. Only the reason behind that is because whenever we do connect a pipe to pipe, or we connect any kind of fittings, there would be a for sure head loss or the pressure drop in that for sure, because of the change in the direction. Okay, so that is the reason we are learning, and this is directly I can say every fitting and accessories or the pipe is directly related to the pump head calculation, because pump head is something which where we come across what are the losses, we try to find out the losses, isn't it? That is what a pump head calculation we will be about to do, okay, in the later on classes. So here, if you can see here, there are some listed fittings and accessories. Let me read out quickly, then we'll proceed with the part 2 of the water side. Okay, so fittings, 45-degree elbow, 90-degree elbow. Then after that, the fitting is like T. One is equal T and one is unequal T. Next is a cross, and next is a reducer. In reducer, we have both two kinds of thing. One is concentric and one is eccentric. So what do you mean by that? We'll be seeing later on. Coupling, if you see, next is a coupling, okay, to connect two pipes, union, nipple, mechanical sleeve, plug, cap, adapter, Y, and so these till Y, you can say these are all fittings. Okay, so we'll be seeing this, what are the different kinds of fitting and what is the significance to use and where it will be used, that also will be learning. Okay, after that, pipe accessories, gate valve or isolating valve. So what do you mean by gate valve or isolating valve? Why the term is given as isolated or isolating? We'll be seeing that also. We'll discuss that. Okay, what is the mechanism? This name is given because of its mechanism, how it works, or for the working principle. Globe valve, then angle valve, then PRV, that pressure reducing valve. So pressure reducing valve is something, a valve, it reduces the pressure of the pipe when the water passes by, okay, passes through it. So just to maintain the pressure or to reduce the pressure within a line, because as per some standards, this is very important. Like if I talk about IPC and UPC, they says that within the water main, I mean the main pipe, the riser, when the water is allowed to fall free from the top. For example, we have I can say tank at the roof level, and that building consists of like 30 floors of the building, and the water, when it is allowed to fall free from 30 floors coming down to serve to the number of the floors which is below. We know this, if something is coming below, it picks up more and more gravity pressure when it comes down. So that pressure within the line should not exceed more than 60 or 80 psi. I'm giving this standards, or I'm giving this with respect to a code called as IPC and UPC. They says that not 80 or not more than 60 psi. So whenever you get that much of pressure, you need to install one PRV within that water main. That is the main pipe or the riser when the water is coming from the above. Okay, so this is to be done, and we have a calculation also, like how to find out how much pressure available at which floor, and you need to show one PRV over there. Okay, next, placement of pressure reducing valve. So as I said, we'll be finding out where, then we'll be showing the way to have a pressure reducing valve. Okay, apart from this, water hammer arrestor. So before moving on with water hammer arrestor, we'll be understanding what is water hammering. Okay, after that, once you understand what is water hammering, then we'll be proceeding on with the water hammer arrestor. As if now only the theory part, the calculation part we'll be doing in a separate chapter. We'll be dealing up with the water hammer calculation also. I mean the water hammer arrestor calculation. Next is a strainer. Strainer is something, you know, it's kind of a mesh, you can say, just to collect the, or to clean out the water, or to collect the debris in the inlet side of the water. Okay, so Y strainer we'll be seeing here, and float valve, foot valve, and NRV. So we'll be seeing different things over here. Okay, float valve, foot valve, and NRV. After that, check valve, swing check, flexible connection, automatic air vent, and pressure gauge. So these again we'll be learning in the chapter number 3. So this is done. Okay, sorry, I missed this. The derivation also we'll be seeing that the pressure exerted at the bottom with the people who are not aware. So we'll be seeing the derivation also. For this is directly connected with the pressure reducing valve. So to get this concept more clear, we have a derivation because this works on some formula. So how that formula has been derived. So we have a formula derivation over here. So this ends up with the chapter number 3 and the part number 1. As I said, once again, part 1 was consisting of 1 to 3 chapters. Now let's move ahead in the water side, part number 2. And in part 2 of the water side, we will be learning is 4th and 5th chapter. So what is 4th and 5th chapter? If you see part 2, 4th chapter is all about the type of the materials. What are the pipe materials we'll be using? Technically, there are only 2 pipe materials. One is metallic and one is non-metallic. So if you see here, this is metallic and non-metallic. In metallic, you have this category of pipes, GI, copper, and CI. Non-metallic, we have a list of piping that is PVC, CPVC, UPVC, PPR, ABS, PEX, and HDPE, and so on. And there are more number of pipes. I think you people are aware of that also, like stainless steel pipes and all this. But as we are dealing with a residential kind of projects and all this, so we don't deal with that. Okay, so if you see here, so we'll be learning is about the piping over here. The reason why we have focused on this pipe material in the chapter number 4 is just to know that what kind of pipe is suitable for which kind of the category of the water supply. For example, some pipes are not good to carry along the hot water. Some pipes are not good in the atmospheric conditions. You cannot let them open in the atmospheric conditions. They might corrode or they might get damaged because of the UV radiation or something like that. So you get an overview idea in the piping material to use what kind of category of the pipe. This is just from our side, but technically this has been decided from the main contractor, or you can say this has been decided as for the client requirement. Okay, so this thing. Okay, next in the part 2, as I said, it consists of 4 and 5th chapter. So 5th chapter is about the basic of the fluid mechanics. So first of all, we'll be learning what are the kinds of the, so if you see here, chapter number 5, fluid of the basic of fluid mechanics. If you see here, types of the flows, laminar flow and turbulent flow. So we'll be discussing what are different kinds of the flow in the line. So what is a laminar flow? What is a turbulent flow? We'll be learning. And as I said, here in plumbing, the fluid, what we are dealing up with is nothing but a water. So we'll be learning here what are different types of the water. We generally know what is potable water, sweet water, hard water, but technical, we'll be seeing what do you mean by potable water, what do you mean by sweet water, and what do you mean by hard water. After that, the main thing comes into the picture, that is nothing but the continuity equation on which the entire plumbing comes around. Okay, that is continuity equation. Then we'll be seeing the flow depends on some parameters like 1, 2, 3. What are that parameters? We'll be seeing that. Again, we'll be dealing Hazen-Williams formula and Hazen-Williams friction factor table. Now, Hazen-Williams formula, we are using it just to find out the pressure drop. Okay, so just to find out the pressure drop within a line, you might use this. And Hazen-Williams friction factor table. Now, this friction factor table gives you the pressure drop for respective materials. Like example, every material has a different pressure drop. Okay, because of the roughness coefficient of that pipe. Okay, internally, not talking about external, because we are not bothered about the external roughness, because we are only bothered about the internal roughness of that pipe. Okay, even if the pipe is like smoother, but still we do have some pressure drop. Okay. After that, we'll be dealing up with the example for the pressure drop through pipe. That means we'll be seeing this one example. Even though whatever the pipe size whatever the pipe material we are using, but still we do get some pressure drop, because we know from the beginning that 100% efficiency we can't expect from anything, right? Likewise, you can't get, even though if I'm using a very smoother pipe internally, but still I'll be getting some pressure drop. So we'll be seeing one example by using this Hazen-Williams formula, so that you get an idea that what exactly this Hazen-Williams formula will be giving us. As I said, it will be giving you the pressure drop. Okay. We'll be doing one manual for example here in this. After that, we'll be learning or just seeing the Manning's formula. This is this is used only in the drainage side, and this is approved formula from IPC. Remember this. But this is used in the drainage side. This is used Hazen-Williams in the water side. Okay. So this ends with the part 2 in the module 1, that is water side. So let's move ahead of the part 3 in module 1, that is water side, and part 3 consists of chapter 6 to 7. So what do you gonna learn in the chapter 6 to 7? Let's move on. Everyone, part 3 on screen, chapter number 6. In chapter number 6, we will be learning what are the different types of the water supply in the building. Okay, like the classification of the building. First of all, we'll be knowing this. What are the classifications of the building? Like in general, if I say, we know this, what is a low rise, what is medium rise, and what is a skyscraper, what is a high rise building. So we'll be learning as per the number of floors, how the building is being classified. What do you mean by high rise building? How many number of floors? What do you mean by low rise? What do you mean by medium rise? Or what do you mean by a skyscraper? So we'll be learning here the classification of the building, then types of the water supply systems in low and high rise buildings. So what are the types of water supply system? Very important. First one is direct water supply system. What do you mean by this? We'll be learning at the time of the project. Like I said, Villa A depends on the water supply system, that is direct water supply system. You deal with any of the project, there would be having some water supply system. in the water side, how the water's been entering into the building or the project. So that is nothing but the water supply system within a building. So here, direct supply system. What do you mean by this? We'll be seeing later on. And next is single booster system. What do you mean by this? Again, as I said, these all systems we'll be seeing when we move in detail in the chapter number 6. As I said, this is just a demo. This is just an overview. So next is single booster set. Third is zone divided single booster set. Next one or fourth one is overhead tank with terrace booster system. Fifth one is a series connected booster system with intermediate brake tanks. After that, we do have more two systems. Series connected booster system without intermediate brake tanks. Previously, it was with brake tanks. This is without brake tanks. Transfer pump system or overhead tank distribution system. Selection of water system based on energy consumption and boosting power. This is kind of, you can say, analysis part, that what kind of system you should select. So this is your analyzing that how much energy consumption is being required in a boosting system. Based on this, you get a graph. Based on that, you can select or you can give a proposal to the client or to the main contractor. If they says yes, then you can proceed up with. Okay. Moving ahead with the chapter number 7 in the part 3. Okay, so here the main technical thing comes. Previously in the chapter number 1, we heard about what is fixture. Okay, what is a fixture? So fixture we already know, but here don't get confused if I talk about the fixture unit. Now fixture unit, it's nothing, or it does not means that how many number of units, or don't count the quantities. Fixture unit is something else. Fixture unit in simple words, or is if now at this moment if I say you fixture unit is something which gives you need to count in the fixture value or the fixture unit value to proceed up with the pipe sizing. Okay. As of now, just remember this much. What do you mean by fixture unit and what do you mean by WSFU and DFU? This both are this both fixture unit is a common terminology in terms of water supply, in terms of drainage, both. So if I talk about the fixture unit or that specific value, that is the fixture unit value. Okay, or if I say that in terms of water supply, then I would be saying with regards to WSFU, that is water supply fixture unit. And if I'm dealing with the fixture unit in the drainage side, then I'll be representing that by DFUs, that is drainage fixture unit. So remember this. So what do you mean by fixture unit? More in technical, we'll be seeing in the chapter number 7 when we deal up with theory for the water pipe sizing. So we'll be getting the theory for the water pipe size and what are the parameters would be like we'll be dealing up. We'll be discussing here more and more to get an idea. And here if you see after that, predefined pipe sizes from standard IPC. That means there are number of pipes which has been predefined from many of the codes. Like you can proceed with UPC or IPC or ASPE, whatever the code. There are some pipe sizes which is predefined. Now you people might be getting in confusion. Then when the pipe size is predefined, then what are we doing over here? At this moment, I'll let you know. These are the pipes which shall be connecting directly to the fixture, and that pipe is called as water supply fixture pipe. So this is predefined pipe sizes, standard velocities for the pipes as per the standard. That means what should be the velocity in a pipe, we need to know. Okay, that depends on the different pipe material. Manual cold water pipe sizing as per IPC. Manual hot water pipe sizing as per IPC. Manual cold plus hot water pipe sizing as per IPC standard. That means we'll be first of all dealing up with manually for the pipe sizing for the cold water, hot water and cold plus hot water, and the source would be from IPC standard. And after that, we'll be dealing with the same example by means of Excel program, and we'll try to do the comparison that what exactly we did in a manual form and what we got in Excel exactly. So then you can develop a confidence by yourselves, because if you don't know Excel, if you directly, I'll give you Excel sheet and I'll say just put the values, you get the output. But the theory behind, but the logic behind, you don't get this. Okay, so that's really interesting, that you should first of all deal up with a manual form. Then you can have more confidence and you get more knowledge. Then you can easily move on with the Excel program. That becomes much easier to understand, because if someone asks you, then it will be very difficult for you if you don't know manual. Okay, so manual, then afterwards we'll be dealing up with the same example by Excel, and we'll do the comparison also, what we got and what we got here. So this was about the chapter number 7 and all about the part 3. Now part 4 consists of chapter number 8 to 10. In the chapter number 8, in part 4, we'll be dealing with estimating water demand. So water demand is nothing but how much water is being needed in any of the projects. So you being a design engineer, they might ask you what is the water demand for the complete project. So you should know this, how much water demand for the complete project. So that can be done by 2 methods. First is people method and area method. So we'll be dealing with both the methods, and people method is mostly commonly used for the public or private applications, and area method is mostly used for the public application. After that, finding total water demand, average water demand, and peak water demand. So you should know this, the total water demand for the complete project, average water demand for the complete project, and peak water demand for the complete project. Okay. After this, chapter number 8, we'll be dealing up with the chapter number 9. This is nothing but the project, that is nothing but the Villa Project A, as I discussed for the water side. Here, we'll be learning Villa Project pipe sizing for cold and hot water. Very first thing, we'll be reading out and understanding the architecture layout. Second, application of the project. Third is deciding the water supply system, like what kind of system we should adopt this. After that, deciding type of flushing system, deciding central electrical water heater location. So you should decide the location of the equipments also. Drawing a single line diagram. Then afterwards, we'll be moving on with the pipe sizing. Under pipe sizing in the Villa project, we'll be dealing up with the cold water pipe sizing, hot water pipe sizing. Okay, then both the sources is from ASHRAE Excel program. Okay, now after this, as I said, chapter 8 to 10 would be in the part 4. So 8, 9 we have seen, and 10 is over here. But before that, chapter 9 is not yet completely done. Then after that, when we have done cold water and hot water pipe sizing, hot water, that was supply, cold water supply and hot water supply here. Okay, if you see here in the chapter number 9, okay, that is part 4. Once we have done with the cold water pipe sizing, hot water pipe sizing, this is in terms of the supply pipe. You can see here, cold water pipe sizing, supply, and hot water supply pipe. Okay, and we have return pipe size also. So for the hot water return, we'll be dealing with the pipe sizing. So we'll be seeing here. After that, pipe sizing for the peak demand. Okay, what do you mean by this? What should be the pipe sizing in terms of the peak demand? Okay, what do you mean by that peak demand? What do you mean by probable demand? More in detail when we move on with the this chapters. Okay, that is 9. We'll be letting you know, and that is again done by as per IPC standard. Okay, next, chapter number 10, still in the part number 4. So chapter number 10, we have water hammer arresters. So we'll be again seeing what is a water hammer arresters, and we'll be sizing the water hammer arresters as per the PDI standards, that is Plumbing Drainage Institute. Okay, and we'll be placing an water hammer arrestor as per the same PDI standards, that is Plumbing Drainage Institute, and selection will be dealing as per these 2 catalogs. One is Zone and one is MyFab, which is nothing but they are manufacturers for this. So by using that catalog, when you get a value, one can select. Okay, just for your information, and then afterwards you can prepare an I can say as like water hammer schedule. You can say schedule, like we know this equipment schedule and all this. I can say as like a water hammer arrestor schedule over here. You can prepare that. Okay, next let's move on with the part number 5. That is, so once again, part number 5. So part number 5 consists of 11 and 12 chapters. In chapter number 11, we'll be dealing up with the tank sizing, and tank sizing we'll be dealing up with as per NBC standards, that is National Building Code of India, IPC standards, or Public Health Engineering Code. This is from local code from India, Odisha. This is directly national code, that is all over India, NBC, and IPC is International Plumbing Code. So we'll be tank sizing by these 3 different methods. Okay, why? Because the climatic conditions may not suffer. So NBC gives some different criteria for that pipe tank sizing, whereas IPC does not gives much. Okay, and whereas public health is doing some other. So we'll be seeing this. What is the difference between the tank sizing as per the public health engineering or the National Building Code of India and IPC standards? So whenever whatever your company is following any of the code, you can proceed with the tank sizing. So there are listed tanks. What we are gonna first of all go with the theory, then we'll be sizing that. So underground tank or the sump. What do you mean by this? Then overhead tank or the roof tank, and the loft tank. So if you see here, there are 3 different categories of tank. One is underground, one is overhead, and one is loft tank. So what is this? Where it can be seen, and what is the purpose to have tanks? We'll be discussing here. After that, some more theory for the underground tank, theory for the roof tank, theory for the loft tank. And what do you mean by freeboard? I think you might have a term as a freeboard. What do you mean by this? So we'll be seeing this. What do you mean by a freeboard, and why to have freeboard? So what and why both is being mentioned. We'll be seeing this. Below that or after that, we'll be sizing underground tank for a private application by people method. So this, as I said, again, I'll be taking with respect to the villa project. We'll try to size up an underground tank for this project. Okay. After that, sizing of the roof tank, for public application. First of all, underground tank, we have sized as per the this private application, that is for the villa project. Now, case 2, we have seen sizing of the roof tank for public application. That means the category of the project is being changed over here, and the type of the tank is also changed. This is roof tank. Next is sizing of the roof tank for private application by fixture method. So sizing of the roof tank for private application by fixture method. Okay, so one can find out the tank sizing by the fixture method as well as with the number of people method. So here by fixture method, and how this values by the fixture method is being developed, I'll let you know that also. Okay, and finding the dimensions of the tank by available volume. That means you need to find out the dimensions of the tank, because it's a design engineer's responsibility to give the dimensions. And if the tank is of like, I can say as a concrete or civils, people will be dealing up with that. Okay, now tank sizing as by NBC standards, that is National Building Code of India. In this, I'll be dealing with people method and area method both. We'll be trying to find out when we are dealing with the tank sizing as per NBC, one can find out when we are dealing with NBC, one can find out the total capacity of the tank, domestic tank sizing, grey water tank sizing. So what do you mean by these three terminologies? What do you mean by total? What do you mean by domestic? What do you mean by grey? We'll be seeing when we were about to deal up or size the tank size as per NBC. After that, I'll be dealing up with the tank sizing as per some disturbance as per the IPC standards. So in IPC standards also, I'll be finding out the total tank capacity, domestic tank capacity, and grey water tank capacity. But if you'll be surprised to know that there would be difference between this and this for the same example. Why the difference and all this we'll be seeing at the time of the calculation, and we'll be discussing in the same chapter, that is chapter number 11. Okay. After that, once this is being done, Once this is being done, we'll be moving on and seeing the sizes of the drain pipes for the water tanks. If the tank is been full, so there should be a drain pipe, okay, or for the maintenance or clean, you need to drain out the water. So what should be the size of the drain pipe size? So we'll be finding out with respect to the standards like IPC. Sizes of overflow and drain pipes for the water supply tank. So you should know this. What should be the size of the overflow size of the pipe size for the tank? Loft tank sizing. So this is third tank. First of all, we have seen underground tank here, and here is roof tank. Here is a loft tank. So loft tank sizing as per NBC and IPC. Again, I'll be dealing with two different standards for the loft tank sizing, or finding out the capacity, you can say, or the dimensions. Tank sizing by Excel program. So after that, once this is being done, I'll try to find out the same example. We'll try to do it in terms of an Excel program. The tank sizing also we can select. I'm having a catalog from a manufacturer called a Syntex. I'll make use of this and I'll try to find out the dimensions. With respect to the dimensions, one can find out, or one can do the selection, the model number and all this. Okay. Then afterwards, one can prepare as an tank schedule also over here, like underground tank or whatever, roof tank or loft tank. Okay, you can give the codings with respect to whatever the code or whatever the catalog you are following or your company is following. Next, move on with the chapter number 12. Now chapter number 12 is something that is water heater sizing. So under chapter number 12, water heater sizing, we'll be seeing first of all what are the different kinds of the heaters. Like we know this unit water heater, central and solar. So we'll be sizing this as per ASPE, as I said, and ASHRAE, that is American Society of Plumbing Engineers, and ASHRAE. By these two codes, I'll be sizing unit water heater calculation, central electrical water heater, and solar. I'll not be dealing with this because solar is not given. Solar from some other code, and solar we have some theory. Then we'll be moving on with the calculation in a manual form. But for these two, unit and central, I have an Excel program. So once we have done with the manual sizing of the unit water heater and central electrical water heater or a geyser, this both I'll be dealing up with manually. Then afterwards, I'll be dealing up with the Excel program for the unit water heater sizing and the central electrical water heater sizing. Solar is nowhere connected with electrical. That's a different concept. So we have a theory over here. After theory, we have the calculation part also here. Okay. After that, one can make a selection also. Once you have obtained the values or obtained the capacities of unit, central and solar water heaters, one can do the selection from the catalog from Jaguar. Okay, so one can find out what should is the make or the model number. And the most important thing, we being a mechanical graduate, and when we are dealing up with the water heater sizing, so it's our responsibility, or we are the concerned person who can give what is the kilowatt needed for this heater to run up. That is for electrical water heaters, I am saying. So not solar, I'm talking about unit water heater and central electrical water heater, so that an electrical engineer does the calculation, gives it that amount, that wire which can bear or which can produce or which can carry that much of the kilowatt that is being needed for the electrical water heater. Either it might be unit or central, that has been used to generate the hot water. Okay, so here we'll be finding out how much kilowatt is needed as per ASPE, that is American Society of Plumbing Engineer. After that, as I said, one can find out again the solar water heater. I'm dealing with the selection here for the solar. Here selection for unit and water from the make Jaguar. Here for the selection of solar heater, I'm using is V-Guard. V-Guard is again one company. I'm having a catalog from this, where by using this, I can select what kind of the solar water heater I need. Okay, because once I got the value, I can select. Okay, then afterwards, I can say when you are aware of this, then one can be able to write a heater schedule over here. That means like serial number, quantity, and where it's been serving, and either it is central or tagging and all this you need to give here. Okay, next, so that was end of the chapter number 5. Now let's move with the chapter number 6, and this is the last part in the water side, that is the chapter number 6. So chapter number 6 consists of 13 and 14 chapters. 13 chapter is the pump sizing, very lengthy, very important. In this, we'll be sizing up the pumps with as per IPC standards, that is International Plumbing Codes. And we'll be seeing here is, sorry, this is part number 6, and the part number 6 is the last, I can say, the part in the water side. Okay, this is a part 6. In part 6, you have two chapters, chapter 13 and chapter 14. In chapter 13, we'll be learning the pump sizing as per IPC standards. And in pump sizing, we'll be learning to design or to calculate the standards of, we'll be learning here to size up the transfer pump, how to do the sizing of the transfer pump and booster pump, hot water circulating pump, roof, booster, and a pressure tank sizing. So if you see here, almost all the pumps is being covered. How to size a transfer pump, the calculation, or to find out the horsepower in simple words. So we'll be dealing up with the transfer pump sizing, booster pump sizing, hot water circulating pump sizing, and roof booster pump sizing. There is one small booster at the roof, so that is roof booster. We'll be seeing that afterwards. With the booster pumps, generally we have a pressure tanks. So pressure tank sizing also, we'll be dealing up with this. Okay, we'll be dealing manual as well as some Excel also. Okay, so this was about the chapter number 13 in terms of the part number 6. Now, chapter 14, the last chapter in the part number 6. So here is a garden water sprinkler system. So here, what is a garden water sprinkler? And what are the types of garden water sprinklers and design of garden sprinkler system. So we'll be seeing this, how to design a garden water sprinkler and what is a garden sprinkler. As of now, for your information, garden sprinkler is something where a jet of water comes out and serves the water to the greenery around it so that it works in a proper manner. And as per the irrigation or as per the type of that, we'll be assisting or we'll be having a sprinkler, what kind of sprinkler for the garden as per the vegetation or as per the like shrubs or the herbs, we do specify that. So, and that's a central kind of system where no humans has been needed over there, just you can on and it does the job. So we'll be seeing this also. Actually, it's not a part of mechanical engineering, I mean this as of now, but we came across a small lawn kind of area in one project, so that is why we have included. But this, for this, if you talk about a garden water sprinkler system, an irrigation engineer is a specified engineer to does this. As this is a small thing we came across, so we included this too. Okay, so this ends with the water side, which consists of 1 to 6 chapters, 1 to 6 parts, and consists of 14 chapters. Okay, so now let's move on with the plumbing, the module 2, that is nothing but the drainage side. And in this drainage side, we do have some like parts. That is like more 4 parts in the drainage side. That is part number 7, 8, 9, and 10. So now if you see here, part number 7, this is the very first part I can say in the drainage side, which includes of chapter 1, 2, 3. Okay. In this chapter number 1, 2, and 3, this is the part 7 starts from the drainage side or the module 2, you can see here. Okay, so in part number 7, as I said, 3 chapters. First chapter is just introduction to the drainage. Second is aims of the building drainage. What is the aim to have a drainage system in a building? What is drainage and what do you mean by silage and what do you mean by excreta? So we'll be discussing it over here. Next, chapter number 2 in the part 7, or the very first part in the drainage system, I can say. So if you see here, chapter number 2 consists of classification of pipes as per usage. So there are different pipes. One is soil pipe, waste pipe, vent pipe, rainwater pipe, and anti-siphonage pipe. So what do you mean by this? How this terms is being derived? What are they doing? So we'll be seeing this. What do you mean by soil pipe? What do you mean by waste pipe? What do you mean by vent, rainwater, and anti-siphonage? So this chapter 2 is all about these things. That is the classification of the pipes as per the usage. Chapter number 3 is, let's see. Chapter number 3 is type of the drainage systems, like we was having in the water supply, like there was 7 to 8 water supply systems, how the water has been entering into the building. Now here, how the water is being going out of the building. These are the drainage systems. I can't say supply. This is drainage. That was water supply system. This is the drainage systems. Drain refers to something which is draining out or which is leaving from one place to another. Okay, so here if you see here, there is a type of drainage systems, but before that we'll be giving you some information. What is a stack? Under that you will be getting what is a single stack system, what is one pipe. Under one pipe you have is one pipe partially ventilated system, one pipe fully ventilated system. These are subcategories in this system. That is one pipe. After that there is a two pipe system. In this also we have two different categories. What do you mean by two pipe system? With a common vent, and two pipe system with individual vent. So under this we have two more categories. Under this we do have two more categories, and this is one, that is single stack system. Okay, so this ends with the chapter number 7. Okay, that is was consisting of 1, 2, 3 chapters in the drainage side. Now module 2 part 8, or else I can say the second part in the drainage side, which consists of 4 to 6 chapters. That means part number 8 consisting of 4 to 6 chapters in the drainage side. Fourth chapter is we'll be gonna learn, or we'll be seeing what is the slope and why the slope is being needed in the pipes. Same thing, slope in pipes, what is slope, and representation of slopes. What do you mean by this? So how the slope has been represented? I think you might have heard 1% or 2% of slope, or 1/4 slope in ratios and all this. We'll be seeing this. What do you mean by this? And what is the significance of the slope in the drainage system? We'll be seeing that also here. Okay. Chapter number 5, we'll be dealing with the project we have changed over here. Previously, we was dealing with one villa project that was residential. Based on the requirement or based on the demand, some people suggested that why don't we people move on with the commercial side? So we have taken some different project, okay, for the drainage side, so that you get an idea that what exactly we are dealing here. Okay, in this we'll be dealing with the sample project. In the sample project, if you see here, we'll be dealing with the entire pipe sizing in the chapter number 5 with respect to the commercial building. So that commercial building is, for example, 5 floors of the commercial building with the commercial toilets over here. So in that we'll be reading that and we'll be understanding the project. Afterwards we'll be sizing the horizontal branch pipe for the wastewater and the soil pipe with the specified slope. Always remember the sizing of the horizontal branch or the waste pipe. What is the horizontal and vertical pipes over here? So horizontal pipe, whenever we are talking about, always in the drainage side, the horizontal pipe should have a slope. Then only the water can drain from one place to another. It can move from one place to another by means of gravity, right? If you rely on that, the same position, it will not. So we need to find out, first of all, what should be the pipe diameter of the horizontal branch. There are two things over here. One is waste pipe and one is soil pipe with the specified slope. What specified slope? Again, as per STUMP standards, that is as per NBC, we'll be seeing this. Okay, that is National Building Code of India. Okay, next, sizing vertical pipe or the stack for soil and waste. So there are two vertical pipes. One is for the soil and one is for the wastewater. So you need to find out the vertical pipe sizes also with respect to NBC standards with the commercial building. Okay. Next, sizing building drain. So what is a building drain? First of all, I'll let you know that. Then what do you building drain for soil and wastewater? So there are two different pipes of the building drain. One is soil drain and one is wastewater drain of the complete building, you can say. and that is also horizontal pipes. So they needs to have a slope. So with the specified slope. See, if you observe in a technical or a keen manner, if you see horizontal branches with respect to the specified slope, vertical, there is no slope because vertical pipe does not need slope. Here, this building drain is also horizontal pipe. That's why it needs a slope. In simple, chapter number 5 is a lengthy and we'll be dealing up with the entire pipe sizing. Either it might be a soil pipe size or wastewater pipe size or a riser or a stack, you can say, and a building drain. So we'll be seeing this in a sample project that is a commercial and as per NBC standard. Remember, this entire is per NBC standard, that is National Building Code of India. Now, chapter number 6, again still we are in the part 8. So here, this is very important. What are traps? What do you mean by a trap and what are traps? We'll be seeing this, and classification of traps. Generally, traps are classified into 2 types, according to shape and according to the work done. Okay, so according to shape, if you see, there are listed are P trap, Q trap, S trap, and bottle trap. So what do you mean by these traps? What is the significance of this, and what is the benefit to have these traps, and what traps prevent, or what are they used for? Okay, we'll be seeing this as per IPC standards also. Okay, and according to use, as I just now said, it is categories into 2, according to shape and according to use. According to use, there are flow trap or Nahani trap. Second is a gully trap. Next is intercepting trap. Here is a grease trap or an interceptor, hay trap, oil trap, and sign trap. Now, if you see here, we are not only discussing, we'll be dealing or we'll be sizing a gully trap, we'll be sizing an intercepting trap, we'll be sizing grease trap or interceptor or grease interceptor, we'll be sizing hair interceptor, oil interceptor, and sand interceptor. So first of all, this intercepting traps and all this, we'll be first of all giving an overview and what it is being used for. And then we'll be saying there where it is being installed and what is the reason to install and how to design that. So we'll be seeing that with respect to some standards, that is NBC standards, National Building Code of India, or IPC, mixed of both. Okay. So if you see this, so this ends with the chapter number, part 8. Part 8 once again consists of chapter 4, 5, 6. Now, 7 and 8 will be coming under part number 9, or the third part, I can say, in the drainage side. So let's move on with the part 9, which consists of chapter 7 and 8. So chapter 7 is a storm water drainage system. Very important, very useful, very interesting. We'll be learning and you people will be really enjoying this. What do you mean by this storm water drainage system? Storm water, I think you got an idea. That is nothing but the rainwater. So what do you mean by this? What do you need to do with that water which has been incidenting on your roof area? Okay, so we'll be seeing that. Okay, stormwater drainage system. First of all, we'll be giving an overview why stormwater drainage is needed. So what is the importance, why you need to have a system? Like we have a system previously, that is water supply system or the drain system. Now, likewise, we do have one more system, that is to be collecting the rainwater. So that is why that comes into picture as a stormwater system or the rainwater system. So why this drain is being needed or why this system is being needed, we'll be seeing. There are certain advantages of the stormwater drainage system. We can be using the rainwater for harvesting, which is also known as rainwater harvesting. And what are the sources of the water collection? Generally, I can say the sources of water collection are from roof areas or the parking areas or the gully areas or the neighbors area, okay, where the water has been incidenting and falling by means of gravity, which is incidenting on the vertical wall which has been connected to house, or in simple words, I can say from the roof, or it might be a sloped roof or it might be a flat roof, whatever the water incidents on that. So we are collecting the water. So these are the sources of the water where we can collect the rainwater. But what are the methods to collect the rainwater? So there are different methods to collect the rainwater. What is stormwater runoff? What do you mean by runoff of the stormwater? One technical term. We'll be seeing this. Then what do you mean by runoff coefficient of materials. Like we have seen what are the different coefficient of the roughness for the pipe. Here we'll be seeing what do you mean by when the water is incidenting on any of the material. For example, there are one is like a roof and one is like sloped area. For example, if I'm saying a sloped roof, that means I'm talking about, for example, I'm saying asbestos. That material is different and flat area or flat roof is different. That is like I can say a slab which consists of like concrete, sand, cement and all this. Okay, so that is different. So here the runoff refers to how much water you can catch hold, because every material will be absorbing or some amount of the water is being seeped out. That means, once again, what I'm trying to say here is if the 100% of the water which is incidenting on any of the roof, it might be sloped roof area or it might be flat roof area, we cannot collect 100% of the water. True. The reason behind that is like 10 or 20% or 30% water would be seeped out. What do you mean by seepage? Seepage is something the water passes a small holes and it tries to divert into it. That means you cannot collect that water. It's been seeped out. Okay. So it differs from the material to material. So you get an information in this runoff coefficient of materials that how much material, how much water can be collected. Okay. Next is what do you mean by a roof gutter and types? Now roof gutter is something where we use these gutters when we are dealing with the sloped roof areas. Okay. An example to size a roof gutter. So we'll be doing one example to size the roof gutter with slope, because gutter needs to have a slope, and a downspout, that is nothing but a rainwater pipe. Gutter is being nothing but it's a way to carry collect the rainwater with a slope that goes all the way to the downspout. That is nothing but a rainwater pipe. This will be dealing with it as per IPC standard. So you'll be finding out the slope, the size, and the downspout or the rainwater pipe dia with respect to the IPC standards. Classification of roof drains. There are different classifications. That is primary roof drain and secondary roof drain. Now the primary and secondary roof drain is like commonly seen when we are dealing with the flat roofs. That is like flat roofs. Okay. We'll be seeing what is a primary roof drain and a secondary roof drain. Then we'll be sizing one example of a designing of a roof drainage network for Hyderabad location as per IPC. So I have included one example of a location Hyderabad with one like a roof area. Okay, and we'll be dealing with this as per IPC standards. Okay, so this is very interesting, and this is lengthy also. It does not looking, but it is very lengthy and very interesting. So now still in the part number 9, and we are heading towards the chapter number 8. In chapter number 8, ventilation in the drainage systems. This is very important. Now you'll be learning what is the importance or significance of the ventilation. If ventilation is not done, then what would be the problems occurred, and all this we'll be seeing. There are different types of ventilations, but before that, what is ventilation systems we'll be seeing, and what is the significance, why ventilation is required. Under ventilation, you have mostly two kinds of ventilation provided in a drainage system. One is stack ventilation or a riser, I can say, if you're not understanding stack as of now. Stack is nothing but a vertical main pipe size here, okay, or vertical main pipe. So here the ventilation is being done with respect to the stack, and we know this stack vent stack. These are vents, or these are all stacks only. So what do you mean by stack vent? What do you mean by vent stack? What do you mean by relief vent? What do you mean by yoke vent? So this comes all under the stack ventilation we'll be seeing. That means the ventilation or the exchanging of air is been happening only with the vertical pipe. So what do you mean by stack vent stack, relief vent, and yoke vent? We'll be discussing this. Okay. After that, individual or the trap, the second classification in the ventilation is trap ventilation. Under trap ventilation, you will be learning individual vents. This is directly connected to the one and only or all the fixtures individually to vent that individual fixture. That is individual vent. common vent, circuit vent, and wet vent. So we'll be seeing what are the different kinds of the ventilating systems in the trap ventilation. Okay. Sizing of the vent stack for the wastewater of a commercial building. Now, what we have learned in the chapter number 5 in terms of the water side, I'll be using the same project, that is commercial project, and we will be sizing the vent stack, okay, for the soil and for the if you see wastewater, same thing, sizing vent stack for the wastewater stack for commercial building, the previous one, same building, I mean the commercial. We are sizing here the vent stack for the wastewater, and again sizing the vent stack for the soil for the commercial building. Okay. Now, once it is being done, this is kind of outdated now. We got a new concept, that is alternate ventilation system. Okay, so what do you mean by this alternate ventilating system? I have taken this source from Terrain. Terrain is one company which manufactures which has come with some wonderful kind of output, which makes life easier, installation easier, and reduces the cost also by two devices that is called as PAPA and I can say as AAV. That is, this is pressurized positive air, pressurized attenuator. And next is AAV. There are two devices, that is automatic air vent. So by these two devices, you can neglect all the previous what we have learned. And this saves lots of time, lots of money, and it becomes much familiar. And this is the future, you can say. And already in some like developed countries, they have already been started using this, and it has been installed also. Okay. So after further learning this, then you will be seeing this. Okay, why we have learned this is very simple over here. Okay, so we'll be seeing this alternative ventilating systems. What do you from the Terrain? Okay, source, I mean the company, they have introduced this PAPN Pleura drainage ventilating system, and benefits of this Pleura system, design and location. We'll be seeing the design and as well as the location for this attenuators and these devices. Ends with the part number 9. Okay, now next let's move on with the part number 10, or else I can say the last part in the entire plumbing, or the last part in the drainage, you can say, that is part 10. In this part 10, we will be dealing with the external side drainage system of the building. Previously it was internal, and in this external side building we have two chapters. One is chapter 9 and another is chapter number 10. So in this chapter number 9, we will be learning what is a septic tank. I think many people are aware what is a septic tank. Septic tank is something which has been recommended from the authority when there is no sewerage or the public sewerage in that particular area. So we'll be seeing here, but don't worry if you're not aware also, we'll be seeing this. What is a septic tank? What is the sedimentation? What are septic tanks used for? And contents of septic tanks, like what are the contents in that of the septic tanks, and how septic tank works, design consideration of septic tanks, location of septic tanks, septic tank designing as per IS, Indian standards. Remember this. So as I said, not any of the code will give you all the details about entire plumbing. So for this, we have one code, and there is one more number over here. I'll give you that when we deal up with the chapter number 9 in the plumbing, that is in the drainage side. So this will be dealing with Indian standards. We'll be sizing a septic tank. Then we'll be seeing when to draw the sludge or the withdrawal of the sludge. Generally, it is like 1 year or 2 years, or it depends on what we are considering at the time of designing. Okay. We'll be using some examples. First of all, we'll be using with the sizing of the septic tank for 20 users as per Indian standards, I mean this code. So we are designing a septic tank for 20 users, then sizing septic tank for 20 users manually by people method. This was previously direct because we have already given this values from the this IS standards. but we will be dealing that how this values is being developed. So to make this, how they have given this values, we will be finding out by using our method, by using manual. We'll be doing the calculation, because here 20 people, they have given the value. It's not done, because if someone asks you to do the calculation, so you can learn it over here. So we'll be doing and finding out this is right or wrong. Okay. Next, in the part number 10, chapter 10, what is a manhole? Why manhole is needed? What is the difference between the manhole and the inspection chamber? Now, many people have the difference, or many people get confusion that what exactly is a manhole and the inspection chamber. We'll be seeing this here. Where are manholes to be provided? We'll be seeing this, where the manholes to be provided. And the classification of manholes, there are 3 types of manholes: shallow manhole, normal, and deep manhole. We'll be seeing what the difference between this. After that, design consideration of manhole. What are the points to be considered when you're designing a manhole? What is invert level? Many people ask this. So we'll be learning or finding out what do you mean by invert level. Next is example to understand the invert level. We'll be sizing, or we'll be dealing up with some examples to find out or to get more clarity about the invert level. Determining invert level for a straight and a slope pipe. So how to find out the invert level for a straight pipe or a slope pipe? We'll be doing it over here by means of one example. Finding slope of invert level. Example 1, we'll be dealing with the manhole sizing. Okay. One example for the manhole sizing, sorry. And one more example will be dealing for the manhole sizing. So there are 2 different examples. One is, the category is different. We'll be dealing with only one. Here, a series of manholes, how to deal up with this. Okay. So these are the things what we're gonna learn in our course of the plumbing system designing. Okay. So this is what entire complete part 10 we'll be learning in the water side as well as in the drainage side. Okay. Thank you so much for your valuable time, everyone. Take care. Good night. Bye-bye. Thank you.